Hey guys, welcome back. In this video, we are going to discuss about two-dimensional array. When we talk about two-dimensional array, all the features from the one-dimensional array applicable for two-dimensional array as well. The difference is, this is having two dimensions. To understand this, it's better to think of two-dimensional array as a matrix. A matrix can be thought of as a grid of numbers arranged in rows and columns, kind of like a bingo board. So we can access two-dimensional array by using row and column indexes. Let's take this array. This is one-dimensional array, right? Here, how you can access the element? Suppose you want to access 3. How you can access it? Array of index, which is 2. Since it's a single-dimensional array, we can access the array like this. Then what about for two-dimensional array? First, I will represent two-dimensional array in diagram. So two-dimensional array will looks like this. These are the rows and these are the columns. Let's write the indexes for rows and columns. 0, 1, 2 and 0, 1 and 2. I hope you remember that array index always starts from 0. So here we can access each and every cell with corresponding row and column indexes. So this one is 0 of 0, means row 0 and column 0. This one is 0, 1, means row 0 and column 1. Like this. This is 0, 2 and this is 1, 0, means row 1 and column 0. And like this, other cells are okay. Now I will declare two-dimensional array in programmatic way. Int two-dimensional array a equal to this line of code is programmatic representation of this. Here, if you want to access 0, you can access through the row and column indexes, that is a of 0, 1. Like this, if you want to access 9 from this array, 9 will be presented in third row, third column, right? So we have to access it like a of 2, 2. For this two-dimensional array, what is the complexity to access the element? If you want to access the element, you can directly use the index of row and columns, that is a of 0, 0. If you want to access this element, you can access it by a of 2, 1, right? So its complexity is 1, that is O of 1. But this is not the case for adding the element in array. We have to travel from one position to another position to add the element in an array. So complexity for the add operation is similar to one-dimensional array, that is O of n. Deletion also like the same. We can't able to directly delete the element from this array. We have to travel again to find the element. So the deletion complexity is also O of n. Search operation is also like one-dimensional array. We have to travel one by one. So complexity will be O of n. Okay guys, see you on the next video.